What's up, everyone? Welcome back to Better Biomed, folks. I have a rather unusual device here, and you guys probably already recognize it for what it truly is. And that is, this is a holiday inflator, which means it has one job, and that is to blow. And right now, this thing sucks. So we are gonna try to troubleshoot this bad boy. And since we are troubleshooting AC electronics, this is a very good time to go through this with you guys, step by step. And I'm sorry for the workbench; it's an absolute mess right now. And that is because I'm working on a project. This guy right here, it's going to be phenomenal. I've been working on it very diligently for the last week, so it's getting so close. I'll show you guys about it soon, but let's go ahead and let's demonstrate what is going on with this bad boy. So the symptoms being, well, major symptom is I just plugged the damn thing in and it is not blowing, right? So nothing's going on there. It should. I've noticed over the past week that the giant dragon that this guy inflates is less and less inflated. It is not seized up, however, because when I rotate it, I can see the drum just from inertia moves slightly. So the bearings are not completely seized up. However, what could have very easily happened is it could have possibly blown a fuse. These are 5 amp fuses, and I just don't see this thing taking 5 amps. And there are fuses right here, and you can see it says open. That means that we got to slide this dingbat open, like so. Come on. There we go. Always use your multimeter probes, of course. And I've got 2 fuses in here. A little bit surprised that I have fused hot and neutral. In most consumer electronics, you're lucky to have a fuse on only one leg. So yeah, we got legs on both. All right, let's go ahead and check it out. A little bit of tap tap. Okay, I got my plug right here, guys, and we're gonna check both the fuses. All right, that's what I was afraid of. Okay, well, that means that it did not blow a 5 amp fuse. That's also a good thing because that would mean that there is some sort of dead short inside this case, and that would not be good. Now, I'm kind of hoping that this is a brushed motor. And if this is a brushed motor, then all these things get a little bit more easy. Our 120 volt comes in right here. And let's see, is it E20? Yes, it is. Okay, let's go ahead and check and see what's going on with the 120 volts as it comes inside the case. I have no idea what kind of motor is in this. I got a rough idea. We're going to find out together if this thing has a brain box. If it has a brain box, it would be right inside here. Okay. And okay, interesting. There's a couple very interesting finds in here. All right, so we have a motor start stop capacitor right here, guys. And any other surprises? Check out this cable right here. You see that? They put these things together so quickly that the cable was right here and it got smashed. And wonderful. Yep. They just smashed the hell out of it, squeezed it. So damaged it a little bit. There's nothing else major going on in here. And in order to test this capacitor, I would need to remove it from the circuit. We're not going to do that at this moment. Okay. We're just going to open this guy up. Fortunately, these things are put together very easily. I mean, it's manufactured in mass and cheaply. And usually when it happens, it's easier for us to take them apart. So I've just got some screws up here, and mind you, they're all plastic to plastic screws, so it means it's threading into the plastic. We got to be mindful of that when we screw them back in, because if we don't find the old threading, we just cut new threading, we could end up blowing out the plastic right here, damaging it, stripping it out. Oh my gosh, why would they do that? Oh my gosh. All right. So we went from T20 to a Phillips. One single Phillips screw. There you have it. Almost the identical length. And they did that. Those guys. And we have one more Phillips screw screwed straight into the base. Darn it. Okay. We got one more right here. Right into the base. We gotta be kind of delicate with this guy because it's a fine thread pitch. There we go. Throw that guy over there. Now, one of the tests that I could have done that I didn't is check for continuity because inside the motor is a coil. And what I'm guessing is that there is a thermal fuse in on the motor hub. And what probably happened because it was rotating slower and slower, probably from wear and tear. I mean, it is out in the weather. It's not like these things get maintained. I'm guessing that it popped that thermal fuse. And that's what you would get right there. You have no continuity on my multimeter right here. So I'm guessing it's a thermal fuse that popped. All right. Let's see. We got, oh, two more. Wow. You would think they'd only put like 4 fasteners on this thing. All right. If it is a thermal fuse, I do have a couple other thermal fuses here in house. Yeah. See, it's not seized up, but all it takes is extra effort on the motor hub itself, and it's going to pull more current and it's going to get hot. And that's when that thermal fuse is going to pop. Okay, so let's see. Let's take a look and see how hard this guy is to get off. Okay. Yeah, it's not going to be cool. All right, let's get more tools, of course. I'm going to go with the needle nose vice grips just because I don't want to have to go back to the toolbox. All right. So it's interesting, the shaft itself, you see that it is completely seized and it's spinning inside this guy right here. Oh, that's so frustrating. So I have a series of screws down on the hub that I got to go through the impeller to unscrew it and pull it up. That's frustrating. But what other options do I have, guys? Let's do it. And again, of course, they're not going to be one type of screw. I've got T20s and I've got number 1 Phillips, I think. They're kind of small. Oh, that is just crazy. Okay, that is, I have chosen wisely. Like I said, guys, there are Phillips screws, and then there was Torx screws, every other one. So I just went and said, let's go for it. Every other one, I went with the T20 Torx because that's what the case was held together with, and the motor hub comes up. Check this out. All right, interesting, guys. Okay, let me zoom in, and I'll show you guys what I'm looking at right here. All right. Okay, now you guys can see it. Check this out right here. It says that it shows the windings and it shows that I have a fuse on my white, which is my neutral. So I have a fuse inside this bad boy, which again certifies what I was saying. It didn't pop one of the external fuses here. It popped one of the internal fuses. I'm really curious. And it says down here that this motor is rated for 0.54 of an amp. It has a 5 amp fuse two of them in here. So that is all very interesting. Okay, so I've got these cables right here. And what I got to do is I got to pull this out. So, okay. And now I've got three fasteners here that are going to open up the back of the motor. Now, the motor looks like it's spinning pretty well. Looks like it. I can't get this blade off. I can get some lubrication down on the front side, but I cannot pull this blade off because right now it's spinning. So I got to pull the back of the clamshell off and then grab onto the rotor, and then I can take this guy off. Crazy. So just a note right here, this is a lock nut, but it is barely threaded into the lock nut. Take a look at that. It is barely threaded in whatsoever. Just garbage. The threads have to go through the nylon in order for the lock nut to be very useful. It's just being held on by corrosion at this point, guys. Let's see. Can I break these loose? Oh no. Wow, those are torqued down hard. There we go. There's one. Okay. So notice how I'm wiggling it a little bit left to right. That's to make sure that it's for sure broke loose. Right. I think we got it, folks. Okay, so this one's definitely loose. I just spin this bad boy right out. There we go. So you can see how I got to reach through the blades. Lovely. I don't know if this one's going to be completely broke loose. There we go. Nice. Don't want to lose any components because I do want to get this dragon back up and going. All right, here we go. If I can leave this impeller on here and actually fix this, then I will do it. Oh, yes. Okay, so here's the legend, the schematic, and it looks like they're just held together. Oh, here's where I stab myself in the hand, folks. All right, let's see. Can I crack it with a set of these cutters? Yep, I can. Nice. Okay, these are flush cutters, guys. But as you can tell, I use my tools for a variety of purposes. All right, now we have a preload thrust washer, and I have internally lubricated bearings. Nice. And it looks like my coils will just slide out, except I'm being held on by that guy. So here's where I'd have to get in there and hold on to it. I'd rather not. My fuse is going to probably be right here. Okay, let's see. I need some more space. There we go. Nice. Okay. What I need is to find my fuse wherever it's at and fix it. Okay. It's almost certainly going to be like right here. So let's go ahead and cut some of the stuff that I'm never going to change out. All right. You got to love that they're using like cotton twine. I've seen where the companies will use fiberglass because it'll get hot. These guys use cotton twine. Got to be really careful not to snip down into one of the windings. That would be very bad. Okay, nice. Let's try one more. All right. So we've got all this fiber right in here, and we got to be really careful because it's really close to those coils. Okay. Here's where these plastic picks and stuff are really going to come out really nice. Oh, shoot. Oh, no. That coil is so loose. Okay. Here, gotta pack that guy down very gently. Okay. So normally windings are wound really tight. On this particular motor, we got some stragglers just kind of sitting out there. I don't know why. It's very loosely wound. There we go. Oh, there's our fuse. Nice, nice, nice. Okay. Okay. So your fuse is going to be right down in here in these connectors, which are covered by like a fiberglass. Right here. So these should be connected to each of the windings. And then one of them is going to have a thermal fuse in it, which I do believe is going to be this guy. We'll go ahead and check them just to be sure. Let's see. Okay, so I got three of them. Wow, they're crispy, guys. Okay, we got three of them. And then right here is my my start stop cap. Yeah, just fell right off. Okay. So right here is going to probably be one of my problems. It's going to be one of the wires coming in. So I got these two white wires. One of these is going to have a thermal fuse on it because you want to disconnect mains from ever getting inside the device. So it's going to be one of these. I don't know if it's going to be that large white one or if it's going to be this one right here. But in series, there should be a thermal fuse. Nuts. Just check it just to be sure. No, there's nothing there. Okay. Okay. We kind of separate it out a little bit. So right here's one. You can see that it's got this black heat shrink on there. It's a little bit sus. So what I'd have to do is I have to cut it open and then go from there. Ah, not cool. Okay. Well, unfortunately, my thermal fuse is going to be right in here. Now let me show you what a thermal fuse is supposed to look like. I do believe I have some of them. And most thermal fuses are going to be an axial configuration. Oh, let's see. I got some axial fuses. Okay. Well, I got some axial fuses to kind of show you. It's not a good demonstration, but close. Okay, so these are called an axial fuse, and that's because they have a lead that comes from each end. And thermal fuses are just like this, only this one's going to be a bit smaller, and it's going to be in series like that. So one of your leads, one of the white wires here, is going to come in on one side, and on the outside, it's going to go to your windings. So that's definitely how they have it set up. Now, what they could do is they could have one of the leads folded over next to it, just like that. So you have it kind of like this, and one of the leads folded over and soldered on, two pieces of heat shrink tube, something like that is probably what you're going to experience. But anyway, I will dig a little bit deeper to see if I can find where this thermal fuse is. But you can tell right now that they epoxied this bad boy in here, which is almost never the case. Almost never the case. But in this case, they glued these on, which is absolutely crazy. So normally I would just cut out the thermal fuse, solder in a new one, and then put on my heat shrink tube. And then I have some floss and some other types of synthetic fibers that you can wrap and tie just like this to re-secure your windings. And then you're good. You just put it back together. But unfortunately for this one, I have to go in and find that white fuse, which is going to be probably right there on that one. Arrgh, and it's glued in. So anyway, guys, not going to have to show you all that. You know pretty much what to look for. And it's especially kind of crazy because here on this device, they actually say that they have a fuse. You can see it right there on the little legend. And that is just so rare. Normally, you kind of have to guess where they're at, and you're going to find these on all types of AC motors right there at the windings. It's a thermal overload. So in case it gets too hot, which is exactly what this guy did, it got too hot and it went kaboosh. I can't get it off. Anyway, guys, I do believe my fuse is right there. I just can't get to it. I'm gonna have to go surgical and see if I can save this guy. But anyway, that is troubleshooting AC simple motors. So first off, what you first should do is check, because there is a coil. Check between these two right here and see if you have continuity. And if you don't, check for fuses. In this case, outdoor devices, they have fuses right here, right inside the plug. Good for them. But also as a reminder that AC motors almost always have fuses, usually right here next to the windings. You can normally change them out really easy. This thing has just been an absolute bear to get into. This entire time, it has been a pain in the butt. And anyway, that's really unfortunate because this guy still wants to run. I can see it. So all I gotta do is actually cut these wires and resolder. You guys get it. I don't have to show you all that fanciness, but just be mindful that there's one other thing with AC motors, and that is a start-stop capacitor. This guy also could be bad. So if your motor's not spinning, first I would check to see if it's seized up. And this one here is definitely not seized up. But if it's just sitting there and humming, then you would cut out this capacitor, remove it from the circuit, and then test it. Mind you, I said remove it from the circuit and then test the capacitor. This one here is 4 microfarads. And if the capacitor tested good, then I would go a little bit deeper. But since I checked the plug and I do not have continuity, that means my coils broke, which would be that magical fuse that it says is inside here. So anyway, folks, there you have it. That is troubleshooting a simple AC motor. And I just got to dig through my supplies, and I'm not going to put you through all that. But you get the gist. We change out the fuse, put that coil, put that winding back together, and then we are off to the races. Thanks for watching, guys. I hope you liked this video. If you do, please give me a thumbs up and stay tuned. I will elaborate on all this project that I'm working on right here soon enough. Good stuff, guys. And I also have some other stuff to show you guys very soon. Oh, I got so many videos to do. It's exciting, but it's a lot of work. Thanks for watching, guys. I'm here to help you guys with any of your test equipment needs, whether you need a quote or you just have a question about functionality. It's no problem. Just go ahead and shoot me an email at jbarber@bcgroupinternational.com or justin@betterbiomed.com. It's my pleasure to help you.